bloodstain or bloodstain pattern analysis.
Materials. The first step we took was to create fake blood. To create the fake blood, we combined food coloring, 50 grams of coffee, and 12 pieces of jubos. We mixed all the ingredients together in a 500 milliliters beaker and added 500 milliliters of water. We stirred and mixed the mixture thoroughly until we achieved the desired viscosity. And this is now the fake blood we are going to use in our bloodstain pattern analysis.
Passive bloodstain pattern generally occur when blood is solely influenced by gravity. This pattern often stems from blood droplets that fall from a wooden individual propelled only by gravity. The dimension, forms, and the quantity of these droplets can offer crucial insight into the type of wound and the circumstance leading to it. These are the subcategory of passive bloodstain pattern: the droplets, pool, and the trail. Droplet, these are individual drops of blood that fall directly onto a surface. The second is pool, is the gathering of blood on a surface when the source of the blood has remained still for an extended duration. The shape of pool can occasionally provide information about the position of the injured individual. In bloodstain analysis, trail patterns pertain to the formation resulting from the movement of a person or object that is bleeding or has blood on it. These patterns offering significant insight into the direction, velocity, and characteristic of the movement. So these are the subcategory of passive bloodstain patterns.
A projected bloodstain pattern is formed when blood is propelled through the air and onto a surface due to an external force or impact. This pattern can provide valuable information about the dynamics of the event, such as the direction and angle of impact, the type of weapon or object used, and the relative positions of the victim and perpetrator. Projected bloodstain patterns can be further categorized into high-velocity and low-velocity patterns. High-velocity bloodstain patterns are formed when blood is forcibly propelled at a rapid speed. This usually happens when there is a significant amount of energy applied to the blood, such as from a gunshot or a high-speed machinery incident. Low-velocity bloodstain patterns occur when blood is propelled at a slower speed, often resulting from less forceful impacts or movements.
A transfer or contact bloodstain pattern occurs when the surface cover in wet blood comes into contact with another surface, resulting in a visible marks or impression. This type of pattern can offer valuable insight into the transfer of blood between objects or individuals. Two common subcategories of transfer or contact bloodstain pattern are wipe and swipe patterns. The first is a wipe pattern is formed when an object passes through an existing bloodstain, causing it to smear or change its appearance. This can happen when a cloth, hand, or any other object comes into contact with a wet blood stain and is subsequently moved across a surface. The second is, a swipe pattern is created when a blooded object comes into contact with a clean surface, resulting in a clear marks. This occurs when a surface is swiped by a bloody hand, weapon, or any other object, leaving a visible trails of blood behind.
To begin the analysis of the blood spatter, we start by placing 1 ml of the suspected blood on a piece of bond paper using a dropper. Afterward, we identify its fundamental components. These components include parent droplet. Parent droplet refers to the droplet of blood from which a satellite spatter originates. Satellite spatter, these are small drops of blood that separate from the parent spatter when the blood droplets make contact with a surface. These are the pointed edge of a stain that extend outward from the spatter. By examining these basic parts, forensic investigators can gain valuable insights into the characteristics and dynamics of the blood spatter.
When blood is dropped onto clothing from a height of 5 feet, it is absorbed by the fabric, leading to the spreading and saturation of the blood within the fibers. As a result, the blood stain on the clothing will have a larger diameter compared to a smooth surface due to the absorption and spreading of the blood within the fabric. On the other hand, when blood is dropped onto a smooth surface from a height of 5 feet, the blood droplet is likely to maintain its shape more effectively. Upon impact, smaller droplets of blood, known as satellite spatter, may be ejected from the main blood stain. The smooth surface can influence the saturation and absorption of the blood stain. In the case of blood being dropped onto a rough surface from a height of 5 feet, the blood droplet disperses upon impact, resulting in an irregular shape stain. The rough texture of the surface causes the blood to spread out, creating splatters and jagged edges. The rough surface also absorbs the blood, causing it to adhere to the irregularities of the surface. As a result, the stain on a rough surface is less defined and more diffuse compared to a smooth surface.
To create two distinct blood spatter, we release the suspected blood from various locations and angles. We release the blood on both the left and the right sides. Afterward, we locate the parent drop on each side and proceed to measure their length and width using a ruler. When indicating the length and width of the blood stains, we first mark the direction of the blood by determining the tail. Then to locate the angle of origin, we use the formula sign of impact, length of blood stain, width of blood stain. This formula helps us to determine the angle at each of the blood originated based on the ratio of the length and width of the blood stain.
To create a distinct blood spatter, we release blood using a spatula. Afterward, we locate 20 distinct blood spatters and proceed to identify their point of origin, axis of origin, and area of convergence. The point of origin refers to the location in three-dimensional space from which the blood spatter originated. It is determined by analyzing the directionality and shape of the blood droplets. The axis of origin is the line that extends from the point of origin in the direction of the blood's travel. It helps us understand the trajectory and angle at which the blood was projected. The area of convergence is the point in space where the lines formed by the axis of origin intersect or converge. It provides valuable information about the location from which the blood was projected. By analyzing these factors, we can gain insights into the dynamics of the blood spatter and potentially gather important evidence for forensic investigations.
Based on the activity of bloodstain pattern analysis, it can be concluded that it is a forensic technique used to analyze the patterns and characteristics of bloodstains at a crime scene. This analysis helps investigators understand the dynamics of a crime, such as the position and movement of the victim and suspect, the type of weapon used, and the possible sequence of events. By examining the size, shape, distribution, and other properties of bloodstains, experts in bloodstain pattern analysis can provide valuable insights into the nature of a crime. They can determine the angle and direction of impact, differentiate between different types of bloodstains, and even estimate the height from which a blood droplet originated. Bloodstain pattern analysis plays a crucial role in criminal investigations by providing objective and scientific evidence. It can help establish the credibility of witness statements, corroborate or refute suspect accounts, and reconstruct the events leading to a crime. Bloodstain pattern analysis is a valuable tool in forensic science that aids in understanding the dynamics of a crime scene and provides crucial evidence for investigations and legal proceedings.